you. Thank you, Nick. Hi, everyone. I'm Chahat Singh. I'm an assistant professor in robotics at mechanical engineering at CU Boulder. So just to give you an overview, so we have a very strong and diverse group of over 10 core faculty members which are affiliated and specializing in robotics. And our research covers a wide spectrum of area, integrating mechanical engineering with cutting-edge robotics technology. And in this session, I will be talking about a few insights and into our faculty research, collaboration opportunities, and unique capabilities that we have at ME. And let's just dive in and explore what makes robotics at CU stand out. So this is an overview where we are highlighting exceptional research output that CU Boulder has produced in the last few years, especially our work being published in Science Robotics, Nature, and IEEE letters, which have been like one of the best places to publish, just to name a few. And our research has also translated into successful startups on the right-hand side that you can see, such as Artemis Robotics, Aspero Medical, and demonstrating the practical applications of our scientific discoveries. And on the bottom, you can also see that over $14 to $15 million have been provided since 2017 in new robotics grants. And you can see the funding agencies that have funded CU Robotics in the last few years. So like things like DARPA, NASA, NSF, NIH, and many others. And as Vera mentioned, having 3 national labs in vicinity to CU Boulder helps a lot. So next, let's look at some grand challenges in robotics. So this is one of the research output that came out from Science Robotics and perspective for the next 10 years. So it's sort of a diagram or a blueprint which lays out the different kinds of applications and core research that goes into robotics. So these are mainly 10 challenges, from materials to biohybrid robotics, power, energy, robot swarm system. And I think the biggest one that everybody is right now working on is AI robotics and brain-computer interfaces, social interaction. Medical robotics has been really big at CU as well, and robot ethics and security. So now I will be going one by one with from each faculty and what their expertise are. So since this is a recording, you will go and look at their websites and try to understand in more details in what they are working on. So I'm going to start with Professor Bertonis, and he has been working, he's a key researcher in our department who is specializing in ultrasounding imaging. And he leads the biomedical mechanics of material robotics and system design group at CU Boulder. And his vision is to bring the value of ultrasound imaging to more patients as much as possible in situations where you can have much better and greater clarity and utility than we ever had before. And his research is focusing on designing system-level solution to clinical imaging problem, which involves from scanning sequences to advanced signal sensing and image processing. Next up is Professor Rensler, who is a professor in our department with expertise in biomedical engineering. He is leading his impactful research at Advanced Medical Technology Lab. His mission is to improve the quality of life for patients by reducing surgical and medical procedures, enhancing physical capabilities, and reducing overall medical costs. And Mark's research is focusing on developing intelligent medical devices and surgical robots. And the team is trying to, rather working on on designing and characterizing surgical tools, modeling patients' interaction with the doctors, and optimizing medical devices that are based on those models. And in good thing about Mark's lab that came out in 2018 is basically he co-founded a startup called Espero Medical, which is a spin out from CU with Stephen Edmund Mosich from CU Entrance Medical Campus. And their company translates their research from bench to bedside, focusing on the GI endoscopy procedures. Next up is Professor Ala Ahmed, and she leads a neuromechanics lab focusing on how the brain controls movement from neurons to behaviors. And this lab aims to reverse engineer how the brain manages complex yet graceful movements that we often take for granted. And this study, and their study is basically biomechanics and the brain computation processes using both theoretical and experimental procedures. And their work covers biomechanics, neuromuscular skeleton modeling, and if somebody has heard of this is like a common thing, Bayesian decision making. That's all the major aspects of their research. And their advanced tools like virtual reality, robotics interfaces, and motion tracking has been really helpful and have played a vital role in like providing insights for human motion control. Next up is Professor Siegel, who specializes in neural interfaces and design of prosthetic limbs that integrate our nervous system or our brain to physical devices. His mission is to enable artificial devices to provide natural sensor feedback, making them feeling the extensions of the body. So it's I would say a very important research for the next 10 years, given that the neural interfaces have been becoming more prominent and useful now. Jacob also serves as managing director at the Center for Translation Research, helping startups secure funding and market their innovations. He holds about 8 patents, co-founded Meta LLC, which Stryker acquired in 2017, and launched Point Design LLC, which create prosthetic fingers that you can see on the right-hand side. Next up is Professor Welker. So Kara Welker focuses on understanding human sensory control and designing of devices that assist humans or augment their motion. Her main mission is to develop devices that individually help with movement impairments and reduce the fatigueness of when we are walking or any other like daily physical day-to-day activities. And her research, just a second. Yeah, my apologies for the interruption. So her research combines biomechanics, haptic technologies, and robotics to create effective assistive devices. And the goal is to interface these kind of devices with human nervous system very seamlessly. So as an extension of human body, essentially. And her expertise include biomechanics, haptic devices, design, biofeedback systems, etc. And the diagram that you see in front of you illustrates the application of her research in both exoskeleton and prosthesis, showing how these devices can enhance human movements. And Kara's work has been has the potential to transform rehabilitation, um, as well as assistive technologies to improve the quality of human life. All right. Next up is Professor Robert McCurry. McCurry leads the Mac Lab at CU Boulder, focusing on advanced computational design and automated fabrication. The lab develops new algorithms, materials, and methods for on-demand 3D printing of functional objects, from surgical models to soft robotics, tailoring to user needs. And they automate the design and fabrication to create functional custom artifacts ready for immediate use, equipped with high throughput multi-material 3D printers and custom fabrication machine. Some of the capabilities include volumetric designs, laser-based material analysis, and high-performance computing for simulations. And this diagram that you see in front of your screen shows a multi-step process of designing a soft robot with embedded sensors and 3D printing. To optimize performance, essentially, and such as running as fast as possible, right? So if you are building a robot, which is of a fixed size, and you want to build it with using materials in such a way that your speed is optimized for the maximum speed. So Robert is an expert in optimization-driven automation and academic credentials in physics and electrical engineering. The Mac Lab's work is transforming how we design and fabricate complex and responsive materials and new devices. Next up is Professor Humbert. Sean Humbert leads the BPRL, or Bio-Inspired Perception and Robotics Lab at CU Boulder. This lab distills biological sensing and feedback principles to design agile and autonomous robotic systems. The lab collaborates with biologists and people from other field to formalize the control principles from nature to robots, and coming up with efficient engineering solutions. So key areas here include sensors, actuator feedbacks, novel sensory motor loops, and architectures and controls of flexible materials. They study bio-inspired sensors, like you can see on your top right of the screen, how bees and insects have some sort of sensory system on their wings. And Professor Humbert Labs made robots that have the similar capabilities, showcasing how efficient the navigation and the controllability of the system is increased by adapting principles from biological beings like bees that you see in this image. Sean Humbert's research bridges biology and engineering, paving the way for nature-based and nature-inspired high-performance robotic systems. So next up is Nicole Xu, who leads an interdisciplinary lab combining robotics, fluid dynamics, and biology to design aquatic robots for environmental monitoring. Her mission is to develop energy-efficient, robust, bio-inspired robots for ocean conservation and climate tracking. Professor Xu has an amazing lab next to the department office. So if you are visiting in November, I would highly recommend you to look like when you are visiting the campus, there's a entire glass of jellyfish tank, which is really amazing, and that's what they're also working on. And their goal is to implement these robots inspired by marine animals to operate in real-world ocean environments, aiding in climate research as well. And Nicole specializes in biohybrid swimming robots, experimental and theoretical fluid dynamics, and field work in coastal waters. And projects include expanding tools to monitor marine diversity using robot jellyfish and designing shark-inspired vehicles for turbulence reduction. And they also focus on robotic fish for aquaculture and near-shore application. All right. And finally, it's me, Professor Chahat Singh, and I lead the Perception Robotics AI and Sensing or PRAISE Lab at CU Boulder. And my work focuses mainly on minimal perception and frameworks for small autonomous robots. Like everybody has seen some sort of autonomous agents in the real world. And the question our lab is trying to ask that can you bring the level of autonomy that you see in self-driving car to robots, which are as small as a credit card or something that can fit on a palm of your hand. So this lab integrates principles from perception, robotics, AI, computational imaging, and all related fields to drive innovation and bio-inspired robot autonomy. Some key projects and research that we work on is high-speed drone or quad-rotor navigation using only onboard sensing and computation, developing micro-scale autonomous drones, and using the newer AI systems like vision language model so that it can autonomously navigate through forests like you can see on the bottom right of the screen. And we are committed to pushing the boundaries of efficient and minimal AI of robotic system to have a real world impact. And finally, I just want to show you this slide, which again talks about the 10 grand challenges as published by Science Robotics for the next 10 years. And you can see that even though we have a lot of specialization in biohybrid robotics and bio-inspired robotics, as well as medical and AI for robotics, all of the faculties combined are working in at least 2 or 3 of these set of subfields. And these are essentially the entire set of people who have been working at CU Boulder in mechanical. Mostly, if you want me to classify these things as medical robotics, you have people on the left-hand side, and more classical and bio-inspired robotic systems are on the right-hand side. And finally, I just want to talk about what exciting opportunities that CU and ME brings, especially when you're working as a specialization in robotics. So our curriculum offers like specialization on courses like advanced dynamics, bio-inspired robotics, wearable technologies, medical devices, and biomechanics behaviors, and advanced computer vision. And most of our faculty members are actively hiring. So reach out to us and find out more. Because since everything has been recorded, you can go back and look into more details in terms of what faculty member, like their contacts and what lab information, and you can go through to understand much better in what kind of work you are interested in. And finally, CU is highly diverse and an interdisciplinary program, which focuses on impacting human lives, society, and environment. Furthermore, we are been spending a lot of efficient time and energy for collaborative efforts among various departments, not only in mechanical, like we have maker spaces at ITLL, IdeaForge, and Netlist, which have been very key contributors for our research and our collaboration. And CU being at the heart of Boulder, we have abundant industry opportunities as well as national lab opportunities, including many startups and CU founded company. So thank you all for being here. We look forward to shaping the future of robotics with you.